Hi everybody. Sorry about that. I had an issue with a cat. That issue was that my cat demands to be pet, like, at all hours of the day. Where are we in administrative? Oh, there's the cat again. I'm great. So to answer the comments in the chat that are going to appear on the screen in a second, you don't get to taste anything in the lab, so you wouldn't get to taste the difference between those anyway. And if you were tasting something, you'd be expelled. That is an absolute no-no. You are not allowed to do that in the class. No consumption of lab stuff. Oh my goodness, my cat, I swear. So my cat wants to be pet all the time. Like, she just wants me to hold her and hug her and pay attention to her. No, we do not actually do that. And if we did, we would not actually tell you that's what it was. Alright, where am I now that the cat has hopefully gotten the clue that, like, stop meowing in the doorway? We're going to continue with Unit 3 today. We'll probably finish it. Some other important things to note are that the first quiz and the first lab worksheet are due on Thursday. You don't want both of those to be due at the same time, so make sure that you've at least started one of them, or at least taken the quiz, or done something. Because that deadline will crawl up on you very quickly. Now keep in mind, those are both soft deadlines, so you do have Friday to do it. I will post last call on Friday, and then that's the last warning you get. Once those assignments close, I don't accept them late without the use of the NQA coupon. If you aren't sure what that is, double check the syllabus. I believe that's really all that there is for Administrivia here. And of course, people choose now to start messaging me. Oh, it's Steve. Of course it is. All right. What are we doing now? We are doing conversions part 2. When you convert one unit to another, like we did in the practice video, or no, wait, we didn't do the practice video for this class. Another class I did the conversions in the practice video. When you do conversions like we did on Thursday last week, sorry, I'm getting my classes mixed up. We did one unit at a time, but it's possible that you can do multiple units at a time, such as converting a velocity from one unit to another. So, for instance, here is a problem. A bullet moves at 750 meters per second. What is the speed in miles per hour? This is very similar to what we have done, but there's a little bit of a difference to it. So what I want to do is give you a few minutes to try and work through it, see if you can get the answer here. And then we'll go over the answer together, okay? So go ahead and get started. Try and convert this from meters per second to miles per hour without just typing it in Google, because obviously you can do that. Use Google to check your answer when you're done, and then type it in the chat when you finish. All right, another minute or two to finish up, and we'll go over the answer. All right. Looks like we have some answers coming in, so I'm going to set up the problem. We're going to set it up just like we did. Oops. First of all, I got to capture the whole problem. You'll notice that I've sort of color-coded this. Because what we're going to do is, so I'm going to have all the length units be in black, and I'm going to have all the time units be in blue. Because what I want to do is I want to convert from meters per second to miles per hour. And so this is pretty straightforward. I could turn meters into kilometers into miles. And there's all sorts of ways to do this. Any number of which you use. You could do meters to feet to miles or yards to miles, however you wanted to. And then for time, I can turn seconds to minutes to hours. When we do our dimensional analysis, we need to cancel out the units that we don't want to get the units that we do want. So I need to end with miles per hour. However I get there by canceling units doesn't matter. So I'm going to turn meters here to kilometers and cancel these out. And then I'm going to turn kilometers into miles here. Cancel those out. And then what I'm going to do is for the next unit, I have miles here. This is fine. I want miles to be in my problem, but I don't want seconds, right? So if I'm going to cancel out seconds, I need to put it somewhere where I can cancel it out. But it started on the bottom, so I'm going to put the next one on the top here. And turn seconds into minutes this way. And then I need to go down here because I ran out of space here. This minutes is on the bottom, so I'm going to put the next one on the top to turn this into minutes to hours. Because remember, you can put these in any orientation you want to. As long as they're on opposite sides of the line, they will cancel. And they don't even need to be next to each other to cancel out. Because multiplication, you can multiply in any order, right? So there we go. Now we have all our units set up. These are the only units that are left over. So when I hit equal, my answer will be in miles per hour. Now I got to do the numbers. So meter to kilometer. I didn't actually write this down, but that's okay. 1.609 kilometers equals a mile. There are 60 seconds in a minute and 60 minutes in an hour. All right, so let's fill in the numbers. In a kilometer, there are 10 to the 3 meters. 1.609 kilometers per mile. And then 60 seconds in a minute. And then 60 minutes in an hour. When you are putting in the numbers, make sure you fill those in correctly. Don't do 60 hours in a minute, or otherwise class was over days ago. And so I'll punch this all in the calculator. I get 1,678.060907 miles per hour. That is way too many significant figures. Let's go check for sig figs. This number has 2. These are exact. This has 4. This is exact. And so is this. This is our 1. 60 is exact. And our 1s are exact. So the lowest number of sig figs shown is 2. My answer should have 2. I don't know what letter that's supposed to be. Sig figs. I would report my answer is 1,700 miles per hour. All right. Oh, wrong screen. There we go. All right. So that's the process by which you do multiple conversions, working with both the top and the bottom. So I'm going to give you 1680 would be incorrect. Yeah, you need to have only 2 sig figs because 750 as written has 2 sig figs. If I wrote 750 dot, then 1680 would be the correct answer. I'm going to give you one of the most common ratios that we use in science, and that is the speed of light. So the speed of light is about 3 times 10 to the 8 meters per second. I want you to tell me that speed in miles per hour, and then I want you to tell me that speed in furlongs per fortnight. If a furlong is 0.125 miles, and a fortnight is 14 days. Okay, so do the first one just like we did the previous one. We did meters per second to miles per hour just now, but then I want you to do it to these other funky units exactly the same way. Okay. So I'll give you 4 or 5 minutes to do that. You can check this on Google. Google does know the speed of light in furlongs per fortnight. So give it a try. And I'll be right back with you in about 5 minutes to go over the answers. How are we doing? Type your answers into the chat once you have got an answer to either of those. And when I see enough answers, we'll go over the answers together. All right, I see some answers for the first one. Go ahead and do the second one. That number I actually have memorized because I've given this problem so often. So I do know that that's the right answer. Please finish up the problems you're working on. We'll go over the answers in about 1 more minute. All right. Where's my pen? There's my pen. Let's go over the answer. So I could scroll this up a little bit because oops, why isn't it working? There we go. I can scroll this up a little bit. So we are going to turn meters per second into miles per hour. This is the exact same process as before. So there we go. Now I've got miles per hour. Let me write in all the conversions here. So we know that 1,000 meters are in a kilometer. We know there are that many kilometers in a mile. 60 seconds in a minute. And 60 minutes in an hour. So let's set up all my dimensional analysis here. So we'll do meters to kilometers. Cancel out my units. We'll do kilometers to miles. Cancel out my units. Actually, we'll just write it right here. So now I got miles in the right spot. I got to do seconds. Cancel it out with something on the bottom. To minutes. And then minutes to hours. Cancel it out. Got all the units in place. Let's put the numbers in. There are 1,000 kilometers in, or I'm sorry, 1,000 meters in a kilometer. There are 1.609 kilometers per mile. 60 seconds per minute. 60 minutes per hour. And I gotta get my calculator out, so let me type all this in. 3 times 10 to the 8. Oops, hold on. Hit another button before that, so. All right, I get 6712243363. That's a really large number. 6.7122 times 10 to the 368, and then my units are miles per hour. How many sig figs should we have? Well, this number starts with 3. These are exact. This is 4. So our answer should have 3. Keep in mind that only your numbers before the exponential count for sig figs. 10 to the 8 is an exact number, so it will never affect the number of sig figs that you have in your calculation. All right, let's do the second one. I got to scroll down a little bit, I guess. So now I need to get to furlongs per fortnight. But what we can do is we can use the previous answer to get to these dimensions pretty easily. So I can do this relationship. 1 furlong is equal to 1/8 of a mile. That's what 0.125 is. And then for fortnight, a fortnight is 14 days. And I can do hours to days really easily. There are 24 hours in a day. So if I take my previous answer and just keep going with it, just be careful. Make sure that you set up your units like this. Whenever you have something per something, that thing that's on the bottom needs to actually show up on the bottom. If you put it like this on the top, oops, I don't know what I'm doing there. If you do that, then it doesn't really mean anything, right? All right. So let's do our dimensional analysis first. I'm going to get rid of miles and just turn it into fortnight or furlongs. There we go. Fortnite is also what all the hip youngsters play. I assume that they're still playing it. Like, I can't imagine that a game that had like 4, 5, 6, 10 million people playing could go under in like a year. All right, so then we'll turn hours into days. So those cancel out. And then, of course, I ran out of space. We'll turn days into fortnights. Cancel, cancel. All right, and so we'll get furlongs per fortnight. All right, let's fill in the numbers. A furlong is 1/8 of a mile, or 0.125. There are 24 hours in one day. And then there are 14 days in a fortnight. And when you punch all that into the calculator, you should get 1.80 times 10 to the 12 furlongs per fortnight. And everything we used in here is exact. So these are all exact. And that's because I told you that, basically. So those conversions are all exact conversions. You do not need to worry about sig figs affecting your result from those calculations because they're all infinite. All right, that's how we do some more complex conversions. We're going to do even more complex conversions now. I'm on the wrong screen. There we go. Oh, not that one. There we go. I was in the PowerPoint viewer. I don't know why. All right. Sometimes you have to work the volumes. And those conversions can get a little dicey because the one-dimensional conversions exist, but the three-dimensional ones have to usually be derived. So what do I mean by that? So, for instance, we know that this is true. In 1 inch, there are 2.540 centimeters. How the heck do I get the cubic conversion for that? Well, it turns out that if I want to get the relationship to the third power, what I have to do is I have to raise both sides to the third power. Now, when I cube one thing, I have to cube everything. Okay, so that means that both the unit and the value get cubed. So 1 cubed is 1. Inches cubed is inches cubed. 2.540 cubed, I need to go to the calculator for that. And I get 16.387. I put 4 sig fig, yeah, there's 4 sig figs here. I'm going to have 4 sig figs out. And then centimeters cubed is centimeters cubed. There you go. So make sure that when you are trying to make a higher dimensional conversion that you are raising to the power of the dimension and not multiplying. It's really common to see people multiplying. So be careful when you are making these conversions because you may need them depending on the application. Now, typically speaking, if this were an in-person class, I would only give you the one-dimensional conversions because there are an infinite number of other conversions that you could make out of that, and there isn't enough space on the formula sheet that I normally would provide you with to put every single conversion in every single dimension. Squared, cubed, to the fourth, the fifth, etc. So I give you all the 1D conversions, and you make them whatever dimensionality you need to. Some problems, such as this one, require you to bounce back and forth between metric, imperial, cubic, linear, whatever. Okay. So for this first problem, I give you a can of soda. Soda has a volume of 355 milliliters. What's its volume in cubic centimeters and cubic inches? Now, a very important relationship for cubic centimeters and milliliters exists, and I hope that you remember it. And that relationship was this. These two things are exactly the same. So when you do the conversion, and you cancel out milliliters and go to centimeters cubed, that's not a very exciting conversion. But that's the answer. So what do we do for the next one then? Well, we can take the answer that we have. And I need to get from cubic centimeters to cubic inches. So what I would do is I would write down the one-dimensional conversion, and then I would cube everything. So let's do that here. Here's the one-dimensional conversion, and then cube everything. So this centimeters right here will become centimeters cubed once those once those three are raised to the proper exponent. I would then cancel out this centimeters cubed with this centimeters cubed, and my units would cancel out, leaving only inches cubed. Because these two things together cancel out with this. Now, you don't cancel out that cubed. You still cube the 2.540. So make sure that you do that. And when I do that, I get 21.663 42915. So I only get to keep 3 sig figs, so I'll just do that. 21.7 cubic inches. If you ride a Harley, your engine displacement might be listed in cubic centimeters or in cubic inches. I have a 883 Sportster. There's a 1200 cc Sportster engine. I don't know how big Harley engines get up to. But after the numbers start getting larger, they start just listing the displacement in cubic inches. So it might just say on the side of the engine block 106 cubic inches or something like that, and that's just that is the volume that your engine cylinders have and displace when the pistons cycle. All right, so there's our answers. We'll erase my ink so you can see that. On the next slide, I'm going to give you a problem with fictional units. Quiz number 3 is full of fictional units. The reason for this is because you could easily just look up any answer online and type it into the quiz and get the right answer. I need to make it more difficult for you. So I'm going to give you these fictional units be very careful that you understand what dimension each unit is. And I'm going to highlight those for you. So volume is measured here and here, whereas length is measured here. Okay? You're going to note the relationship here, and you should be able to make an analogy to what these units are. So I'm going to give you this question here. Oops, I didn't mean to tab through it. I'm going to give you this question here, and what I want you to do is I want you to tell me the volume in this unit based on the conversion that I've given there. And then finally, I want you to tell me the volume in cubic inches based on the conversion that I give you here too. Okay? So you have weird units, but you have a way to get from the weird units to a unit that's known, because I give you inches. Okay? So you are literally doing the same things that you did on the previous slide, but I'm just giving you foreign units that don't exist in our world. And then the last thing I want you to do is, once you get the volume in cubic inches, I want you to tell me the size of the creature that would drink from this teacup. So, like, if you had, like, an animal on Earth to compare it to, would it be like a mouse that drinks from it? Would it be an elephant? Would it be a person? Try and estimate, based on the answer that you get, if the cup of tea is very large or very small. Okay, because it's impossible to tell from the number I give you. That's just a bonus question, so we'll see if you can do that. We'll go over the answers together in just a moment. 1 or 2 more minutes to go over the answers? Or, I'm sorry, to finish, and then we'll go over the answers. Okay, let's go over the answers. Okay, so first I got to do that so I can write on my sheet. So I have, let me move my screen here. I have this volume and this unit. And what I want to do is I want to get from that volume to this volume. And the conversion that is given to me is that one of these is 32.5 of these. So that conversion should not be terribly difficult to set up. Because we just match up the units like we've been doing all along, right? Okay. And then I fill in the numbers. 1 and 32.5. And I think you do get 4940, but let me punch it in the calculator just to check. Yep, 4940. Okay, great. Now let's turn this into inches cubed. And the relationship I have here is that 1 inch equals 15.5 blargs. But this isn't cubed, and these are not. So what I need to do is I need to cube everything. So let's do that. So I'll take this number down here. And I'm going to multiply. Let's set up the units so that they cancel. This is going to get cubed eventually, so I got to set them across from each other. And then we'll put in the numbers. And then we'll cube everything. So now these cancel. Excuse me. So now I take 4940 times 1 cubed divided by 15.5 cubed. And I got 1.32 6.5, so 1.33 actually. Inches cubed. And that's the answer that we would report. All right, how big is 1.33 inches cubed? What size creature would drink from a teacup that held 1.33 cubic inches? A rhino might be a little big, or maybe you're on the right track, because the answer I came up with was Roadhog. There he is. And there's our answer right there. Oops, I can't draw on that, but that's okay. There we go. There you go. We were talking about popular games before. We got Fortnite. Now we got Overwatch. People still play Overwatch, I assume, right? I don't. I'm not good at shooters. Also, I hate playing with other people. So we count the sig figs on 15.5. Yes. Because I did not tell you that it was an exact conversion. That's what I need to do. I need to hold that button. I did not tell you it was an exact conversion, so we would assume that it is approximate. Now, the 1 is always going to be exact. But any other numbers are approximate. And even if we didn't do that, so if we said that this was exact, this one still has 3 sig figs because the previous one had 3 sig figs. So our answer would still have 3 sig figs anyway. All right. When we come back from the break, guess what we're going to do? If you said more conversions, you were right. So let's put this up here. I gotta go back to the Metroid music. I'm gonna hit start on the timer, and I will see you in about 10 minutes. See you in a bit. There we go. Let's turn this down. We're close on that. Let's see here. What do we got in the chat? Wonder if an oak would be a good answer. I mean, Roadhog is pretty big. So when a student said rhino before, I was like, I think Roadhog and a rhino are actually pretty similar in size. Particularly if you were thinking about, like, say, Rocksteady. All right. In any problem I give you, you may find conversion factors just sort of hidden in the story. This is common when you have to convert 2 units from one to another that don't really make sense. So I might ask you about, like, a puppy has this weight. How much food should they eat in this much time? And so, like, we've got weight and time, and those 2 units are different. There must be a way to convert between them, because there normally isn't a way to convert weight to time. Okay, so we're going to look at problems where there is an unusual conversion factor somewhere in here. Speaking of food, let's suppose you eat 2 pounds of food per day. That's a lot of food, by the way. How much food will this person consume in 85 years? Now, 85 is not measured. This is this is not exact. It is a measured quantity. So what we would do for this problem is we would say, okay, so I have years, which I know how many days there are in a year. I didn't mean to actually write the number. And then I know how much food in pounds is eaten per day. So there are 2 pounds of food in 1 day. And when you see the word per, that means you can make a relationship there. And then we know the number of days in a year. There are 365.25 days in a year. Because we don't know if that year was, we don't know which years are leap years. And in 85 years, you're definitely going to hit a leap year. You're going to hit like 20 of them, actually. All right, so let's set up our problem. Let's turn 85 years into days. So those cancel out. And then we've got days, and then food. Oops, I don't really want to write that unit that way. Let's just write pounds. There we go, that's what I wanted. All right, let's prepare to be disgusted with ourselves. All right, I can't imagine people eating 2 pounds of food a day. But let's say that you are a Roadhog. 62,092.5 pounds. Now, I only get 2 sig figs out of this, so... In other words, 31 tons of food. And what goes in must come out, so the next question is no. Stop. We are not answering that. So, for this problem, our unique conversion factor was this right here. And these conversion factors can hide anywhere in a problem. So, be on the lookout for those. All right. Let's do a different one. This was my pay rate, like, a while ago. I don't know if this has changed or not, but I'm paid $82.50 per hour to teach you guys. How much money do I get for all the lectures we're going to do this quarter? Now, before you answer the question at all, like before we do any work, Ask yourself, wow, that seems like a lot of money, or that's not very much money. And then answer the question. Because you'll see why the pay rate is so high for an hour when you think about it. So try and solve this question and tell me how much I should get paid for this class in 1 quarter. We'll go over the answers in just a second. All right, I see that people have the correct answer. It is 3,300, which is not that much. Let's go over that. Oops, gotta capture question. All right, so we'll scroll down. Actually, I'll just do that. All right, so what conversions do we have here? So we have 8250 per hour. And then there's another conversion that's hidden in there. We've got 1 lecture equals 2 hours. And so to start the problem, I tell you how many lectures I give. I give you 20 lectures. Which we can then turn to a number of hours, which we can then turn into money. Which is what we're all here for, right? We're all working for the weekend so that we can get our money or whatever. I don't remember the song. All right, so we have 20 lectures. And then we can set up our units so that they all cancel out. Now, it's kind of coincidence that these are all working out so that they are just numbers that we multiply along the top. That is not common. So the result that I get is 3,300 dot total. And so let's check. So 20 lectures, this is counted. Now, depending on how strict of a definition you want to go here, I'm not intending to round. Our lectures are 2 hours, so we go from 2:30 to 4:30. So this is intended to be exact. And then this is 4 sig figs. So this number is written as good to 4 sig figs. That's not a lot of money. That's why I teach 3 classes. But also, that's just the lecture part. I'm also paid for the lab stuff, which makes up a different chunk of it. So I do okay at the end of the day. I think that, like, you can actually look up my salary. Like, it's public record. But I believe that for a 140 class, the entire class is around $6,000. But then what you also have to factor in is that for things like prep work and grading and designing the assignments and stuff, which I had to do every quarter, the amount that I'm paid for that is 0. So it ends up being very different than this quoted value right here. In fact, I think I actually did the calculation, and being a faculty member ends up being about 27 to 32 or so dollars per hour. So, faculty don't get paid that much, it turns out. Like, if you want the big bucks, don't teach. I happen to really like teaching a lot. This is the only job I could ever see myself doing. But I don't do it for the money, that's for sure. Why is 20 not counted for sig figs? Because it is a counted number. I give you 20 of these lectures, 2 a week, and they're 10 weeks. So I can actually count them 1, 2, 3, 4, 5, 20. So because it's a counted number, it is an infinite number of sig figs. Like, I don't give you a third of a lecture or something like that. At least, that's the intent. Lab time this quarter is technically free. Yeah. I do the lab time because I feel that putting an extra few hours per week for both office hour and lab helps you guys a lot. But if you look on the course catalog, you'll notice that the only instructor that does 3 days a week, 2 hours a day, is me. Everybody else does 2 hours a day, 2 days a week. Because I'm technically I'm contracted to work with you guys for 4 hours a week. I do 6 because, 1, I need the extra time to get all the material done because I do way too many examples and then talk to you guys like this. And 2, it helps you guys. And what else? What the fuck else am I going to do, right? So yeah, I could meet twice a week and probably do as much, but I don't think you guys would do as well. So whatever, it's 2 extra hours a week. So that means I'm being paid even less per hour, but that's fine. I make enough. I could speedrun Zelda. I do that on Thursdays. Usually. I stream with a bunch of friends, and on Thursday we do Zelda. Do I have a second problem here? I do. Okay. So here are the last 2 conversion problems. Money is a very common conversion type of problem because you can always buy something for a fixed amount of money. And so I might ask you, like, what quantity of blank costs this much money? Or how much do I need to pay to get this quantity of stuff? So what I want you to do is tell me how much I have to pay for 1 metric ton of aluminum. Now, note that this conversion right here, this is exact. But this number up here is not, okay? So just be mindful that your answer will depend on that 1.000 metric tons. Because I can't put a blob of aluminum out. I don't know if aluminum is measured in blobs or not. That weighs exactly 1 metric ton. But I can certainly define what a metric ton is. In the second problem, I want you to tell me how much sodium is in the human body. If all of that sodium is concentrated in blood. 1 pint of blood has 1.52 or so grams of sodium, unless you're extra salty because you go on Twitch or something. Then you'll have more. Assume that you have about 10 pints of blood. You might have to Google up some of these conversions. If you don't know grams to pounds, for example. So go ahead and do these two problems. Type your answers in the chat. We'll go over the answers together in about 5 minutes or so. And then we'll finish off the chapter. All right, 1 or 2 more minutes to go over the to finish, and then we'll go over the answers. All right. So let's start with this first one here. All right, so I know that 1 pound. Oops. Wrote over my letter. There we go. Of aluminum is $0.9317. Now, the reason that we care about those fractional cents is that if I buy 1,000 pounds of them, that will matter. Those numbers down there will affect the cost. So it's set to that amount. I have no idea if this is the current cost. When I wrote this slide, this is what aluminum cost. So yeah. All right, so I have metric tons is the amount that I want to purchase. Stonks, yeah, that's right. I'm going to convert metric tons into kilograms because I have a relationship for that here. It's 1 metric ton equals 1,000 kilograms. I can then turn kilograms into pounds and then that into money. So looking up all my relationships, 1 kilogram is 2.204 pounds. And then 1 pound of aluminum is 93.17 cents. There you go. So let's do the conversion. We'll start with the metric ton that we're buying. And I don't want metric tons, so it's got to cancel. We're going to turn that into kilograms based on our little blueprint over here. We're going to turn kilograms into pounds. And then pounds into cost. All right, so we should get an answer in dollars if we do this math right. Let's do the numbers. So 1 metric ton is 1,000 kilograms. And then a kilogram is 2.204 pounds. And then 1 pound of aluminum is 93 cents and 17/100ths of a cent. This is another one of those problems where, oh, all the numbers, you just multiply them together. Again, that doesn't always happen. So be mindful of that. $2,053.47. Now I got to consider sig figs. So this is 4 sig figs. This is exact. This is 4 sig figs. So is this. And these two ones are exact. So my answer should go to 4 sig figs. $2,053. Close enough for government work. What I intended in a previous lecture was that you need to be doing dimensional analysis like this where you're canceling things out. If you are choosing some other method, the second that you get to in-person classes and show that to somebody, they'll just start marking everything wrong. So do the problems using dimensional analysis. When I say dimensional analysis, I mean this part. So this right over here is just the prep work. And because this is a prep class, I do the prep work for you every time. What if you did it backwards? I'm not really sure what you mean by backwards. Because you'd have to have the answer before you could work backwards. I don't know how you would go from money to tons, since you have to solve for the money itself. If you started with the conversion, so if you started with this quantity, then the issue you might run into is that you have that flipped the wrong way. And so that is not recommended. Like, try and find the thing that is not the conversion. So, like, in this second problem, what's not the conversion? It's the 10 pints of blood, because that's just the quantity that we're starting with. So that's what you're going to start with on your planning. Like, this is what I want, and this is what I start with. And I know that how much sodium there is per pint. So there's my plan there. Yeah, because you could get really lost if you weren't just starting with the number by itself. Don't start with a conversion, because the odds that you have to do this to it, I mean, it's 50-50, right? You're just picking, if you use it just how it's written, you might have to use it backwards. In fact, in this problem, you do use it backwards. So for pints, 2 grams of sodium, I know that in 1 pint of sodium or of blood, there are 1.52 grams of sodium. And then in a pound of sodium, there are 453.6 grams of sodium. So let's start with the amount of blood. And then we'll turn pints into grams of sodium. Canceling that out. Oh, we don't use it backwards in this one. Okay, never mind. And then grams of sodium to pounds of sodium. And then we do the numbers. So in a pint of blood, there is 1.52 grams of sodium. And in a pound of blood, there are 453.6 grams of sodium. Exact. The first two numbers we had are 3 sig figs. This one's 4. Our answer should have 3 sig figs, so I'm just going to write it to 3. What do we got? 10, 1.52, 453.6. And I got 0.0335. So not that many pounds of sodium in the human bloodstream. There you go. That's how you do those. I'm going to give you problems that are just filled with random conversions, and then you'll have to use normal conversions to answer what I am trying to get at. Okay? So these types of problems will be pretty common on the exam, or on the quizzes in the exam. All right, let's do the last section. Let me see how much I have left of the slides here. Oh, there's like 4 slides. Okay, so cool. All right. Last thing we're going to talk about is percentage. Percentage is just another conversion. The way that percentage is defined is how much of something meets a criterion out of 100, right? So, for example, if I said 52% of the students in this class were first-year students, then that would mean if I had 100 people in the class, 52 of them would be first-year students, for example. If I had fewer than 100 students or more than 100 students, you could use that as a ratio and multiply as we need to. And you're going to see that in just a second. So here's the formula for it. You can get the percentage of anything by just taking number of interest items divided by total. So you're not required to have 100. Doing the division and then multiplying by this, by 100% here, makes it into an out of 100. You may get a fraction. That is fine. Follow the rules for sig figs. We're going to use this as a conversion factor. Let's do an example here. I don't remember when I took this data, but in one quarter that I taught Chem 140, 37 out of 45 people passed the class, so that's C or better. What percentage of students passed the class? Well, okay. What's the number of items of interest? We want to know how many students passed, so that would be this. How many total students were there? There were this many, times by 100%. So 37 divided by 45 times 100. I get 82.22 forever %. Now, I'm putting infinite number of sig figs because these are all counted. So I technically do have to write all those too. I'm not going to do that, obviously. And then down here, I just rounded it to 2 sig figs. Important to note that this is a definition. So that 100% does not affect your sig figs because it is just a number that we use to make the unit do what we want. This 100 and this percent sign go together with the result that we would get over here, which would be a decimal. So this is a decimal. Because any number divided by a total that is larger than the number will give you a decimal. All right. Let's do some more examples of this. Let's suppose that I have a 5 kilogram steel alloy bar, and I know that the bar is 94% iron by mass. What is the mass of iron contained in it? And pretty much everybody knows how to do this. Oh, you just times 5 by 0.94. But let's show how the units actually work out in this type of problem so that you can do it using dimensional analysis. All right, so I know that for a steel bar with mass 100 grams, 94 of those grams would be iron. And that's based on the definition of percentage, right? Because if I did this times 100%, I would get 94%, which is what was stated. So now what I can do is I can take any mass of steel and do this relationship. So let's do that. 5 kilograms of steel you'll notice, oh, this is in grams, so I need to convert this to grams. So there we go. And now that I know how many grams of steel I have, I can say, okay, how many grams of steel? 4 grams of iron. And that's going to be this right here. And so now I can just fill in the numbers. So a kilogram is 1,000 grams. And I know that for every 100 grams of steel I have, 94 of those grams are iron. When I do that... Oh, oops. I have a mistake here. Sorry. 5.0. Here's how much iron is in there. I could then turn this into kilograms if I wanted to. I didn't actually ask you which unit to put it in. So as long as you gave it to me in a mass, that'd be correct. Alright, let's do another one. Air is 21% oxygen by volume. How many milliliters of oxygen are in a 1.25 liter sample of air, such as in, say, your lungs? Because that's about the volume of them. How would I do that? You do it the exact same way. And you do that by just writing a percentage out. So in 100 whatever unit we want of air, let's say liters, 21% of that would be oxygen. So 21 of those liters would be oxygen. So now I can do the dimensional analysis. I have this much air in my lungs. Just take a deep breath. And then hold it. And then hold it. It'll all be over soon. We can do the dimensional analysis here. Oh, actually, you know what? Let's do the units first. So liters of air. Now I have liters of O2. But the problem wants us to do milliliters, so we'll just do that. This relationship goes here. And then a milliliter is 10 to the minus 3 liters. There you go. And I got 262.5 milliliters. Those numbers are 3 sig figs. These are all exact. 100 is exact because it's a part of our percentage. Our answer should have 3 sig figs. There you go. So that's how you use percent. Just like all of the other dimensional analysis we've done in this chapter, apply it just like you would any other problem. Alright, so I'm going to give you these two problems. So the first one, I tried to find a list of all the words that were allowed in Scrabble, and the latest dictionary I could find was 2015 when I did this problem. There are this many words. That is a space indicated that there would be like a comma there, okay? I put a space for larger numbers just so like you don't have to count 3, 6, 9, 12 places or whatever. So there are this many words allowed in Scrabble. Of those words, 5,846 are 4-letter words. What percentage of playable words don't have 4 letters in them. Okay? So be careful. I don't want to know the percentage of playable 4-letter words. I want to know playable non-4-letter words. And then down here I have trimix. Trimix is a mixture of oxygen, nitrogen, and helium when you go scuba diving. It's particularly useful for deep diving because if you have too much nitrogen in your air mixture and you go down too deep, you get what's called the bends when you resurface, where the nitrogen is so pressurized it turns into a liquid, and then when you go up it tries to become a gas again, and your veins get bubbles in them, which is very, very bad. Helium won't do that. Helium will remain a gas, and so you can have a gas with the correct pressure in your lungs. Here's the composition of trimix. 21% oxygen, 35% helium, the rest is nitrogen. How much of each gas is in a 12-liter scuba tank? So, do these percentage questions. We'll go over the answers when we have about, let's see here. We have 10 minutes left, so I'll give you 5 minutes to do them. I'll do the answers in 5 minutes, and then we'll call it a day. Okay? See you in a bit. All right, we're going to run out of time if I wait too much longer here. So let's go over the answers here. Oh, I got to get rid of this little dotted line here. All right. So there are 5,846 four-letter words of a total of 277,663 words that are allowed. So if I wanted to find the percentage of four-letter words, I would do this math. Now, I actually want the percentage of words that are not four letters, but we can still use this information as shown. And so the result that I get is 2.1054%. And there are more digits after this because I technically get infinite sig figs here. So this percentage are four-letter words. So what percentage would be are not four-letter words? Well, that would just be 100% minus this number. And this is exact, right? That's 100.00000 forever. So I'll just do 100 minus my answer. And I get 97.894 6%. And so however many sig figs you want to report for that. The other way you could do this is you could subtract these two numbers and then do a percent. Either way works. Now let's do this trinix question. So what I'm going to do is do this problem basically 3 times here. How did I get the last number? This right here, the 97.98? I subtracted, so this is just subtraction. Because 100% would be all words. If I subtract out the four-letter words, what I'm left with are the not four-letter words. I guess it's not technically air, huh? So we'll call it trimix. And so what we're going to do is we're going to make a ratio here. Let's suppose that I had 100 liters of trimix. Well, according to these percentages, 21 of those liters would be oxygen. And so then these would cancel. And I could get the volume of oxygen in a 12-liter scuba tank. So 12 times 21 over 100. And then what I'm going to do is I'm going to go like this. And we'll just replace it with the other percentages. So 35% of it is helium. So 35 of these 100 liters would be helium. And then I just do the same thing. And then the rest is nitrogen. So what I could do is I could say, okay, well, 21 plus 35 is 56%. So the remainder must be 44%. And do it that way. So we get rid of this guy and say, okay, well, if it's 44% helium, or I'm sorry, 44% nitrogen, then this must be true. And I get this. And then as a final check, you should add all of these together and see if they add up to 12. 8 plus 2 is 10. 5, 7, 9, 10. 5, 9, 11, 12. And it checks out. All right, that's it for percentage. If you have any questions, let me know. I think that might be the last slide. Hopefully it is, because we don't have any... Oh, no, there's 2 slides left. Darn it. Okay. Well, we're going to do percent error on Thursday. But because percent error is like 1 slide, I will finish that on Thursday, and then we'll move on to chapters 4 and 5, which are both very short. So let me just move this ahead really quick. Oops, I didn't mean to do that. I meant to do this. So what I'm going to do is I'm going to put the quiz up for Unit 3 tonight. Because we've more or less covered all of it. We just have one topic left to cover, which is 2 slides. But we're out of time for the day. So that quiz will be unlocked tonight. It will be due a week from today. So please do that soon. Make sure that you get quiz number 1 and lab worksheet number 1 done by the deadline as well. And you'll be in good shape. Thanks for coming to today's lecture. I hope that it was informative. I will see you tomorrow for a Q&A and to answer any questions you might have. See you then.